So in this video, we're going to talk about graphing piecewise functions. On the test, parts you're going to have a calculator and parts you're not, because I do want us to understand how to graph without just completely relying on our technology. So in this first example, I have two pieces of the graph. The first is y equals 2x plus 1, and the second is y equals x squared. So I know that when I have an x value less than 1, my graph looks like y equals 2x plus 1. The first thing I want to do is, what does this graph look like at the end of the first part? So when x equals 1, I know that I have a y value of 3. So this first part of the graph is going to stop at 1, 3, because 1 is the cutoff x value. So 2x plus 1 is going to be a line, but it's going to stop at that point that I just drew. It has a slope of 2, so I know I go down 2 over 1. And this left part of my graph, or the first part of my graph, looks something like that. It's a line. If I could draw straighter, it should be straight, but it's a line that stops at the point 1, 3, and then has a slope of 2 to the left. The second part says when x is greater than 2, the function looks like y equals x squared. So now that I know that this part of the graph starts at 2, so when x equals 2, I know I have the function x squared. So this function is going to start at 2, 4. Little trick here though. It starts at 2, 4, but there is not a line underneath my inequality. There's not a line. So since there is not a line under the inequality, when I go to 2, 4, here I'll do this in a different color. When I go to 2, 4, I'm going to have an open dot. Then with the line, I knew I had a slope of 2, so I can move on from there. A quadratic doesn't have a slope per se, like a linear. So we're just going to have to plug in numbers. So I know that when I plug in 2, I get the point 2, 4, because 2 squared is 4. The number right next to 2 is 3. So when I plug in 3, 3 squared is 9. So I know I have a point 3, 9. And then the next point would be 4, 16, but I don't have room for that. So the quadratic looks like that. So this has two pieces to the puzzle here. The first is a line, y equals 2x plus 1, which I have graphed. The second is a quadratic, y equals x squared. So I know that when x is less than 1, I graph the line. When x is greater than 2, I have the quadratic. So just like the last one, basically when we're graphing these, we're going to graph one at a time. So this first one, it's a throwback to the very beginning of the year. It's the absolute value function is what those absolute value bars mean. This starts at 3. So I'm going to plug in 3. So when x equals 3, so y equals 5 minus 1. So I have the point 3, 4 on the graph. So when I plugged in 3, I got 4. Now, it says x is less than 3. There is not a line underneath the inequality. So I know the point 3, 4 is an open dot. But for all values less than 3, I know that the absolute value part's true, so I need to go left of the point. I know that absolute value, the vertex of the equation, oops, what is going on? The vertex is right here at HK. So I know the vertex, or the lowest point on the absolute value, is at -2, -1. And then, with absolute value, we talked about how this number out here is the slope. So if I don't have a designated slope out there, I know it has a slope of 1. So a slope of 1 just means we go up 1 over 1 in both directions. Because remember, the absolute value has a vertex, which is why I graphed the vertex. And it makes a V. So the left part of my graph looks like that in blue because it's an absolute value function, and absolute value functions look like V's or upside down V's if it's been reflected. So we have to identify the vertex of -2, -1. I know the graph ends at 3, so I had to stop at 3. Since there is not a line underneath the inequality x less than 3, I know that at the x value of 3, it is going to be an open dot, not a closed one. So the second part of the graph is the quadratic. And we're going to see what does it equal at 3. And it appears actually it's going to be off the graph, which is unfortunate for my example choice, but we're already 6 minutes in. So when x equals 3, I plug in 3. And I get 16 plus 1, or a y value of 17. So I have the point 317 is where it starts. Well, 317 is like way up there. So that's unfortunate. But since there's a line underneath the inequality, I know it's going to be a closed dot up there. And then I need to start plugging in other numbers, basically. So I do know, similar to the absolute value has a vertex at HK. A quadratic also has a vertex at HK. So I know the quadratic has a vertex of 7, 1. Because my H value is 7 and my K value is 1. I know that when I plug in 5, let's plug in 5. So when x equals 5, we have y equals 5 minus 7 squared plus 1. So y equals -2 squared plus 1. So y equals 5. So the point 55 is on the graph. And that's good enough for me to get this part. And then if I plug in, I don't know, let's say 9. Because I'm plugging in 9 because 9 is to the right of the vertex. So when x equals 9, we also get 5. And if we remember how a quadratic works, if there's a point 2 to the left at 5, there's also a point 2 to the right of the vertex of 5. So my quadratic is not beautiful here because the point 317 is off the graph, and I apologize for that. But basically we're going to start at the starting point of x is greater than or equal to 3. So I'm going to start at the x value of 3. And when I do that, I get 317, which is off the graph, so I had to put it way up there. Then I know the vertex is at 7, 1, so I went ahead and plotted the vertex at 7, 1. And then I want another point on each side of the vertex just so I can kind of build my U a little bit. So I built my U. I plugged in 5 because that was right next to the vertex. Then I plugged in 9 because that was right next to the vertex. And I was able to graph it. So remember that when we're graphing piecewise here, sometimes there's 2 parts, sometimes there's 3 parts. It doesn't matter. You're going to graph each part of the piecewise function individually. So this part I graph the absolute value piece first with its endpoints. Then I graph the quadratic piece second. It doesn't matter which one you do first or second, but you need to do both of them separately. If we see these as 2 different entities, it'll make graphing easier than confusing ourselves and thinking that it's all one continuous curve.